Okay, so after our last video, we were talking about the difference between positive and negative integrals, what they mean. So I've kind of set up some examples here with our little visual so we can understand what we're looking at, and then I'm going to put them into application terms. So, again, I've got this visual. This first integral, we're going from -1 to 1. So that's finding this area. Looking at that right now, I can tell that that area is below the x-axis. This area should come out negative. So let's take a look here. Antiderive, so I'm going to get x cubed over 3 minus x, and I'm going to evaluate from -1 to 1. So I plug in 1, that's 1 cubed over 3 minus 1, and I'm going to subtract, I'm going to plug in -1 cubed over 3 minus -1. So 1/3 minus 1, that's going to be a plus 1/3 because the negative cube stays negative, and then I'm going to subtract. This is plus 1, and then I'm going to minus it. All right, so I have 1/3 plus 1/3, which is 2/3, -1 minus 1, so that's -2. So common denominator, that's going to be -6 over 3. So my answer is -4/3. If it's all positive or all negative, that is going to tell us our total distance. Okay? So since all of this was negative, this is telling me from -1 to 1, I went backwards 4/3 units. All right? So, I'll clarify this here in a second. This negative just is giving us direction, and then 4/3 was our displacement here. Okay, now if we look from 1 to 2 on our graph, 1 to 2, we're seeing this area, which is all positive. So our answer should be a positive number. Again, our antiderivative is x cubed over 3 minus x. And now I'm going 1 to 2. So I'm going to plug in the 2. I'm going to get 8/3 minus 2. And then I'm going to take away 1/3 minus 1. So 8/3 minus 1/3, that is 7/3. -2, take away a -1, that's -1. So common denominator, I end up getting a positive 4/3. That's interesting. I didn't even mean that, and I got it. That's kind of cool. So I might change that last one to make this look even more interesting. Okay, so here we get a positive 4/3. So this is positive 4/3. This is -4/3. I'm going to make sure I did that right. I hope I did. 2, negative, yeah? Okay, I feel good about this. So I'm actually going to change these bounds over here to make my point more clear. We're going to go from -1 to 2. So now I'm going from -1 to 2. This is an integral property we're going to talk about in a couple videos, if not the next video. What do you think is going to happen if I combine this integral with this integral? I'm assuming our area should come out to be 0. Because I'm combining this integral, which was -4/3, with this integral, which is 4/3. So let's see what happens. Antiderive, I still get my x cubed over 3 minus x, evaluated from -1 to 2. All right, so I get 8 cubed minus 2. And I'm going to take away, this is going to give me a -1/3 plus 1. Okay, so 8/3, so that's going to be 9/3, which is 3. And then I've got -2 take away 1, which is -3, which is 0. All right, so what do these mean, and what's the difference here? Why did I go through this conversation? If all of our area is positive, what we're looking at is our total distance traveled. If it was all negative, total distance traveled, but backwards. So what happened when I combined my negative distance with my positive distance? I got 0. But we can clearly see there is area under this curve. So how can it be 0? So that's when we look at the interpretation. Our integrals from A to B, no matter what, positive or equal, this is giving us our displacement. So from my starting position to my ending position, how far did I move? And in this case, nowhere. Because my negative distance equaled my positive distance, so my displacement was 0. If we look at only positive values, so I'm going to absolute value my function. So that would take this piece and actually make it look like this. Now my negative 4/3 is a positive 4/3. Now I'm looking at total distance traveled. I went backwards, then I went forward, combine that, and that gives us our total distance traveled. So total distance. Or you could say, instead of like total distance, this is our total net change. Okay, hopefully that makes sense. Yes, we can have negative area. It gives us different information, but our integrals won't always give us that area or the total distance. Yeah, it doesn't even give us total area because this one gave us 0, but we definitely had area there. It was just combining the negatives and positives. Hopefully this makes sense. If not, hit me up, like and subscribe. See you around, guys. I'll be here.